Hello everyone. Today we are going to discuss the Surds topic, so which is related to IIT. So it will be useful so much in IIT problems. So let's see definition of the Surds. So what is the definition of the Surds? I'll make you to understand here. If n is any positive integer or n is any natural number, belongs to n is natural numbers, and a is belongs to positive integers or rational numbers, which is greater than 0, we can say. Then if I write nth root of a, it is called a surd. If n is belongs to natural numbers, a is any positive rational number, then nth root of a is called surd. This is the simplest way of defining the surd. Here, if the n value, if I'll take like this, so if nothing is mentioned here, so we have to think that 2 is present here. So this is called a quadratic surd. This is called a quadratic surd. So if n is equal to 3, means cube root of 2 or cube root of 3, like this if you'll write. So when n value is 3 here, so it is called a cubic surd. If n value is 4, means 4th root of 2, 4th root of 5. So these kind of things are called biquadratic surds. Biquadratic surds. So those are the definitions I gave here. If n is a positive integer and a is any positive rational number greater than 0, then nth root of a is called surd of nth order. So if that n value is 2, it is second order or quadratic surd. If n value is 3, cubic surd. If n value is 4, biquadratic surd. So very clearly I told here, quadratic surd or second order surd, you no need to mention the 2. Just if you write like this, it means that it is a quadratic surd. That means the square root of 2. We can call it as square root of 2, means pronunciation. How can we pronounce that? So square root of 2. Here it is. These all like this I can call like cube root of 2, fourth root of 2, fifth root of 2, like that. Depends on the power. So this is the definition of the surd. So comes to the types of surds. So here we have simple surds, mixed surds, compound surds, binomial surds, like this. What is meant by a simple surd? So root 2, this is a simple surd. Cube root of 3, this is a simple surd. Fourth root of 5, simple surd, means the surd which consists of a single term is called a simple or monomial surd. So these are the examples. These are the examples. So next comes to the mixed surd. In mixed surd, one number should be rational number, one number should be rational number, and another should be a surd. So the combination of these two is called mixed surd. That means I'll give an example here. 2 plus root 3. Here 2 is a rational number and root 3 is a surd or simple surd. So the combination of rational number and a surd is nothing but called as mixed surd. So the general form of this mixed surd will be in this way: a plus root b and a minus root b. Next comes to the compound surd. In the compound surd, with the example I will tell you, here 2 or more, sum or difference of 2 or more surds, like root 3 plus root 2, root 3 minus root 2, like root 5 minus root 7, or root 3 minus root 7, or root 3 plus root 7. So here both are surds only. Sum or difference of the 2 or more surds, means root 2 plus root 3 minus root 5. So like this. So these are the examples for compound surd. So comes to the binomial surd. Binomial surd is the compound surd which consists exactly 2 terms. So like this one. So root 3 plus root 2 is one best example for binomial surd. Means in this binomial surd, exactly 2 surds will be present, combination of 2 terms. So that is binomial surd. Next comes to the similar and dissimilar surds. So when it comes to the similar surds, like root 2, 5 root 2, 3 root 2. So outside multiplication may be different, but the surd should be same. So maybe multiplicative coefficient is different, but the surds should be same. So these kind of surds are called similar surds. These kind of surds are called similar surds. So what is mean by dissimilar surds? Root 2 and cube root 3. Cube root 3. Their order is not same. So these and here radicands also not same. So these kind of surds are called dissimilar surds. So dissimilar surds. Next comes to the conjugate surds. So what is meant by conjugate surds? So conjugate surds are nothing but like this. If I'll take any two mixed surds like 3 plus root 2 and 3 minus root 2. If I'll take the sum or product, sum and product, sum and product. Sum should be a rational number. That the two mixed surds which I took, its summation also should be a rational number. See here, if I'll add these two, so you'll get the 6. 6 is a rational number. Or if I'll do the multiplication of these two, 3 plus root 2 into 3 minus root 2. So here a plus b into a minus b. So it is in the form of a plus b into a minus b. So we can write a square minus b square. That means we can write this one as 3 square minus root 2 whole square. Square root gets cancelled. So 9 minus 2, 7. So this is also a rational number. So like this, when two mixed surds, whether you will add or if you multiply that, you should get a rational number. So sum and product of two mixed surds is a rational number. Then we can say that the two surds are, means here, these are the surds I'm talking about. So these two surds are called conjugate to each other. Conjugate to each other. So this is the definition. If both sum and product of two mixed surds is a rational number, then we can call these two surds as conjugate surds to each other. So next comes to the loss of radicals. So here we have few laws. So one is nth root of a into nth root of b is nth root of ab. So nth root of a by nth root of b, we can write nth root of a by b, and mth root of nth root of a is equal to nth root of mth root of a is equal to mth root of mnth root of a. So how we will get this one is, see, mth root of a, we can write like a power 1 by n whole power 1 by m. So that means we can write this one as a power 1 by m whole power 1 by m. Both are same. These both are same. That's why this can be written as nth root of a. Or from here, by using a power m whole power n formula, we can write this one as 1 by m into 1 by n, a power m into n. That is a power 1 by mn. So that's why this also can be written as mnth root of a. So now comes to the when we can add or when we can compare the surds, means when the surds are having the same order, then we can compare the radicands. So if the order is not same, first we have to reduce them into the same order, then radicands to be considered. So we have to note down these 2 points. So let us see the examples based on this. So how can we compare the terms here? So here I have the question, greatest among these. So first let's look at this 6 into cube root of 5. Another one is y is equal to 8 into cube root of 2, and another one is z is equal to 2 into cube root of 130. Then w is equal to cube root of 900. So one by one, see, if you look at this all, its order is same. Its order is same. So this outside values, whatever we have multiplicants to this, so this we have to send inside and we have to calculate it into the same platform. So let's see how can we calculate this. So what I will do is, here I will send the 6 inside the cube root, then it will become 6 cube into 5. So this will become 6 cube into 5. So what we will get the 6 cube into 5 here. So when you will see the calculation of this one, So 6 cube is nothing but 216. So 216 into 5 is cube root of 1080. You will get x value. So comes to the second one, y. So y is equal to cube root of, so when 8 I will send inside, it will become 8 cube into 2. So this will be cube root of 8 cube is 516. So 516 into 2. So you will get 1024 as the y value. Next comes to the z value. So z is equal to cube root of 2 cube into 130. So that is cube root of 8 into 130. That means cube root of 0. So 8, this what you will get? 4, so 0, so 1040. So W, no need to calculate, they are already given cube root of 900. So if you look at this all now, all are of the same order, outside also no number is multiplying to these surds. So we can compare the radicands happily. So if you are comparing all the radicands, so x is the greatest among the all. X is the greatest among the all. So, and another way, how can we write this one is x is greater than z, which is greater than y, and which is greater than w. So here greatest one is x and least one is the w. So this is the way how can we compare the surds of the same order. So now let's see this one. Now radicands are same, but order is not same. So let's look at this. So 6th root 2, cubed root 2, and 4th root 2. This is what they are given. So how can we write this one? We can write it as 2 power 1 by 6, 2 power 1 by 3, and 2 power 1 by 4. So order is not same. So what I told in the previous session is, so order first we have to bring it to the same. So let's reduce that. For that, what we have to do is we have to take the LCM of 3, 6, 4. So let's solve 3 ones, 3 twos, 4 will be like that only. Next 2 ones, 2 twos. So LCM of this one is 3 into 2 into 2, which is 12. So let's make it 12, denominator of every power. So 2 power, to make it 12, I'll multiply and divide with 2 here. So it will become 2 by 12. So for the second one, I'll multiply and divide with 4. So it will become 4 by 12. So for the third one, it will become 2 power 3 by 12. So this we can write like 2 power 2 whole power 1 by 12. So 2 power 4 whole power 1 by 12. 2 power 3 whole power 1 by 12. So how can we write this in the next step? So we can write this one as 12th root of 2 square means 4, and 12th root of 2 power 4 is 16. 12th root of 2 cube is 8. So among these all, the greatest one is this one. That means 12th root of 16 is greater than 12th root of 8 is greater than 12th root of 4. So from the given question, how can we write this is cube root of 2 is greater than 8 we got for the 4th root of 2 is greater than 6th root of 2. So this is the way how can we solve the problem. So next we'll take one more question. So let's see this question. Ascending order of the following. So what is the ascending order? Means small to big. So let's calculate here. They are given 10th root 3, 4th root 2, 5th root 5. So let us take it like 3 power 1 by 10 and 2 power 1 by 4 and 5 power 1 by 5. So here radicands are different. As well as its order also different. So let's make it, let's bring the order into the same first. For that, let's take the LCM of 4, 5, 10. 2 twos are 5, let it be like that only. 2 5s are 10. So next we will take 5. 5 ones are 5 ones. So 2 5s are 10. 20 is the LCM. So let's make it 20. So for that, what I will do is I'll multiply and divide with 2 here. I'll get 2 by 20. Here I'll multiply and divide with 5. So 5 by 20. So here 5 power 4 by 20. So we can write this one as 3 square whole power 1 by 20 and 2 power 5 whole power 1 by 20 and 5 power 4 whole power 1 by 20 we can write. So that means 20th root of 9, 20th root of 32, 20th root of 625. So among these, which is bigger one, I mean greatest one? So greatest one is this one, second one is this one, third one is this one. So ascending order. So therefore, ascending order of given one is, so 10th root 3 is a smaller one. So next 4th root 2, next we'll get 5th root 5. That means 10th root 3 is lesser than the 4th root 2, lesser than the 5th root 5. So this is the ascending order of the given problem. So one more type of problem based on the comparison. So if you look at this problem, greatest among root 37 minus root 7 and root 43 minus root 13. So if you look at the difference between these two, 37 minus 7, you will get 30, and 43 minus 13 is 30. So if I'll rationalize this one, easily I will get it to know which is the greatest one. So what I will do is I'll rationalize this one, root 37 minus root 7. So rationalization in the sense, by changing the sign, we can multiply and divide the same term here. So that will be root 37 plus root 7 divided by root 37 plus root 7. So these are called rationalization. So numerator will be a minus b into a plus b. So it will be a square minus b square divided by root 37 plus root 7. That means we will get here 37 minus 7 by root 37 plus root 7, which is equal to 30 by root 37 plus root 7. Next comes to the next one, 43, so root 43 minus root 13. So here rationalize this one again. So we will get root 43 plus root 13 by root 43 plus root 13. So a minus b into a plus b, you will get 43 minus 13 by root 43 plus root 13, which is equal to 30 by root 43 plus root 13. So now see, for the both numerators are same. So comes to the denominators comparison, root 37 is lesser than the root 43. This we know very clearly. Root 37 is less than root 43, and root 7 is lesser than root 13. When I will add these two, root 37 plus root 7 will be less than the root 43 plus root 13. That means here this denominator is smaller one and this is greater one. So if greater the denominator, then the whole fraction will be lesser the value. So 30 by root 37 plus root 7 will be greater than 30 by root 43 plus root 13. That means we can say that root 37 minus root 7 is greater than the root 43 minus root 13. Means this is the greatest one in these two. So this is the way how can we solve the comparison of the surds. So here are the some questions for the homework. So please do these questions as the homework. So its solutions will be discussed in the next classes. For more classes and more IIT topics, please subscribe to my channel and support my channel. Thank you all.